Okay, so what we're going to look at next is the activity series itself. How to read it is our first step. The next step is to see the activity series itself and use it. So we'll do some example problems. Can I move on?
Yeah.
No? Not yet? Okay. That's okay. I chose this method because I don't want to write on the board. Take your time. It's almost empty. It's not good. It's not good for me or you. Specifically, when we talk about metals, we talk about if it's an active metal, it's easy to lose electrons. For nonmetals, it means the opposite. If it's an active nonmetal, it's easy to gain electrons. Hello. This is on Canvas. Okay? All right. Now can I go forward? You good? Okay. All right. The order that they are listed in the table you're about to see is determined experimentally. Okay, so this is all information that we did in experiments to figure out whether or not it would work. The most active element is going to be at the top of the activity series. It can replace anything below it in a compound. This activity series only applies to single displacement reactions for our purposes. Again, this is the most important part of this section. The most active metal at the top can replace anything below it in a compound. All right. Okay. Do we have this written down? So we're going to use this piece of information to help us predict whether or not these reactions are going to occur. In order to do it, we need to look at the activity series, which is on the next slide. Here are the three we're going to practice. Hopefully you can see them on my board. Those of you following along at home, I'm going to switch so that you can see my board. You're going to want to put the activity series on your screen while you're watching.
That's Cu.
Yes, that's copper, Cu. This is potassium. That's HOH, so that's water, right? Sometimes in these reactions we will see water. I'm always going to recommend you rewrite it, okay? Because the metal in water is what? The H or the OH? Look at the periodic table. That H is located on the left side for a reason. It can act as a metal or a non-metal. In this case, it's acting like the metal because there's a metal that's trying to replace it. Okay, so we'll talk about that too. All right, so let's look at the activity series. Okay, so real quick. elements can only replace in compounds if they are higher on the activity series. And we're going to start with metals first, and then we'll look at nonmetals. So these three are all metals based. Can I move this forward? Are you still writing? Anybody? Okay. All right. So here is our activity series. If it's hard to see, I'm going to recommend you open up your slide on your screen, because you're going to need this today during class. Okay? I recommend you open up this lecture. It's like 4 slides. This is the last slide. Okay? And we're going to spend the rest of class practicing this concept on purpose so that you feel pretty good about reading the activity series. And we're going to go through and we're going to do this the way I'm going to ask you to do it on your quiz. So the first thing I'm going to ask is, what is being replaced? And the answer will either be a metal or a nonmetal. Okay? Part B, what's up?
Will we ever need to memorize that, or will we have it?
The activity series?
Yeah.
You would always be given the activity series. I would never ask you to memorize that. That's mean. Okay, so the first question is, what is being replaced, metal or non-metal? The second question is, does the reaction occur? This is going to be a yes or no. The last thing will be to predict the products. It's going to be fun. And balance. Okay. So let's start with letter A. The first question says, what is being replaced? So let's look at the actual question. It's lithium solid plus HOH, and we want to know which thing is going to be doing the replacing. Now remember, in single displacement reactions, we can either replace the metal or the non-metal. Remember, we did A plus B, X makes AX plus B yesterday, okay? So in this case, lithium, metal or non-metal? Metal, okay? This is the easiest way to determine this first question, is to look at the thing that's by itself in its elemental form. If it's a metal, then a metal's being replaced. If it's a non-metal, then a non-metal is being replaced. Okay? So for A, the first answer is metal. The second question says, does the reaction occur? Okay, so now let's determine, using the activity series we just said, that if it's going to happen, the element that's going to do the replacing, meaning the thing that's by itself at the beginning, has to be higher than the thing it's going to replace. So let's identify. This is the thing that's going to be doing the replacing, right? You agree? So this has to be higher. The lithium must be higher than the thing it's going to replace, which is, in this case, we just said, the hydrogen, right? The hydrogen acts as the metal here. The OH is a polyatomic ion, the anion. If you're having trouble distinguishing in water what's getting replaced, remember, this would be positive, this would be negative, and metals are always positive, right? So remember that. So is lithium higher than hydrogen on here? So locate, you got lithium all the way at the top. Whenever you have lithium solid in a reaction, your answer better be, oh yeah, it's going to react, because lithium will replace everything. Hydrogen's all the way down here. But remember, hydrogen's not going to be seen as just H, right? Hydrogen is going to be seen as H2, because on here, oh no. Because H2 is going to be a diatomic element, right? Even though it's technically a metal. Okay, so this is going to react, right? Will react. There's your answer. to A and B. All right, last thing, predict the products. Two approaches. You have to figure out what the new compound is going to be, right? You know that the lithium is going to replace the hydrogen. So you know that lithium is going to attach to whatever it is. When we make compounds, remember they are supposed to be neutral. The charge on hydroxide is what? -1. The charge on lithium is what? +1. So is that correct? Yes. And it's going to make what else? H2. Nice. Okay. So that was the second part. The other thing says to balance, right? Is this balanced? No. How do we balance it? Ooh, that's a 1. Too bad. So that last step is to balance. Good so far? Feeling good? It's not so bad. There's just a lot of steps. This is the order I will ask you to do it for every single one. Okay? First, determine what is going to be replaced. Determine if it's actually going to occur or not. If the reaction doesn't occur, you just write DNR or no reaction, and then you move on. You don't have to do anything else. So those are the nice ones. All right, let's do the next one. So the metal that's by itself is barium. What's being replaced? Since barium is a metal, the metal must be replaced, right? The thing by itself is the thing that will be doing the replacing. If it were going to do the replacing, what would it be replacing in this compound? Potassium. So, we want to locate barium and potassium. Barium must be higher than potassium for this reaction to work. So we look at our our table of metals. Barium is here, potassium's above it. So does this reaction happen? And you're done. You do not predict products, you do not balance. You just write no reaction. All right, do this one on your own. Try to identify the metal, non-metal, or the metal that's being replaced. Locate them on the table. Determine if they react or not. If you have a question, raise your hand. Done? It's fixed. I think I've got a marker. Where am I marking this? When you're done, look up at me so I know you're done. Sir?
Is that copper?
That is copper.
Okay.
Ooh, question. Do you think the metal or the non-metal is going to get replaced here? It's definitely metal. So remember, hydrogen can also be the metal that doesn't replace it. Okay? Whenever you see hydrogen gas like that by itself, it's always acting like metal. Okay, just moving forward. And you can tell because this is the activity series of non-metals, and there's only 4. That you'll ever have to worry about. Yeah. Okay. Everything else will be metal. Okay, so now, hydrogen is the metal. And what's the metal in the one on the right? The one that's positively charged, right? So copper. So where are they in relation to each other in the chart? No,
have a new computer.
Yeah.
So,
This is below.
yeah, so does the reaction occur then? Yep. Okay, so now we're going to put H in place of copper and copper by itself. Because it's a single displacement, remember?
All of these symbols.
Yes, they're all going to be single displacement. Good question. So now we want to make,
Would it stay two?
yes, but why?
Because that's what I said.
Nope. Because this is what charge?
Negative.
2. Okay? And H is always going to be plus 1. Right? Because of where it's located, so then it would be H2SO4. Okay?
All right, so does this reaction occur? Yes. What gets replaced, a metal or non-metal? Metal. And it occurs. What's one of the products? Single displacement, so copper by itself, okay? In the other thing, hopefully you remember that SO4 is a -2, and when hydrogen binds to an ion, it's going to be what charge? Based on its location? +1. So the other thing you should have written should have been H2SO4. The trickiest part of these is not, does it react or not? The trickiest part is remembering how to write your formulas for neutral compounds. Yes? No. Do you mean like on the right side? No, not at all. As long as you're actually writing a single displacement reaction. Okay, let's do one with a non-metal. Same exact process, except we're going to replace something different. Yes?
How do you know to put like the Erzberg's behind copper?
Oh, anytime a metal does that, it's going to be a solid. That's a me thing, that's not a you thing. You can assume that if it's a transition metal or any of the metals in groups 1 or 2, that it's going to be a solid when it's in that form by itself. Okay? It's called elemental. if you will. Yeah.
So was hydrogen like the only element that you can put like the 2 next to? But
For
you can
this
put it both?
particular, yes, good question. Hydrogen is the only diatomic element that will ever be a metal. That's a good question. It's the only one on here, do you see that? That acts as a metal that has that too. That's a really good question, Braden. Okay, so hopefully you notice it's the only diatomic element that is also a metal. Yes?
What is the activity of halogens?
That's what we're going to do next. So the halogens on the far right are what kinds of elements? They're non-metals. So remember, we said, part of our question was, what is being replaced? The metal or the non-metal? Now, let's do a non-metal replacement. The same rules apply. A non-metal can only be replaced if it is hotter than the thing it's trying to replace, right? So a non-metal can only do the replacing if it is located higher than the non-metal is attempting to replace. All right, so let's do one. I'm going to do 2. Might as well. Sorry, you don't have to worry about states in this particular exercise. I don't want you to stress out about knowing if it's a gas, a solid, a liquid, or an aqueous solution. It doesn't matter. What does matter is that you can do the replacing and you can predict the correct products. Okay, so the first one, answer the question. What's being replaced, a metal or a non-metal? A non-metal. You always look at the thing that's by itself and identify what type of element that is in order to determine metal, non-metal. Since F2 is a non-metal, that's the thing that's going to be replaced in this. Or going to do the replacing, if you will. In order to determine whether or not the reaction will actually take place, you need to look at your compound and determine where is the non-metal in the compound. It's always the negatively charged thing, okay? In the particular case of the activity of halogens, you'll notice there's only 4 to deal with. There's not so many infinite scenarios for us to do here. What we need to realize is that the thing that is positive is the metal, the thing that is negative is the non-metal, always, okay? So F2 is trying to replace chlorine. Can it do so? Is it located higher than chlorine? Yes, it is. So this will react. Okay? Now we predict the products in balance. These are going to switch places, right? So I know one of the things is going to be Cl2 because chlorine is a diatomic when it's by itself. And I know the other thing is going to be that. Good? Okay. Let's do the next one. Metal or non-metal being replaced. These ones are obvious because I'm trying to prove a point here. Non-metal. What's the second thing I'm looking for? The thing that's trying to do the replacing must be located higher than the thing it's attempting to replace. Can bromine replace chlorine according to the activity series? It cannot. So you will write does not react. Yes?
Is the first one, like, is it balanced?
You tell me.
It doesn't look like
Doesn't look balanced to me. What do you do? Yeah, don't forget to balance them. Okay, there are practice problems posted on Canvas for you to start doing this on your own. Get this. Yes?
Are all halogens diatomic?
Not all. Not all of the halogens are diatomic. Not all nonmetals are diatomic. Remember, there's only those 7, right? Remember we talked about like the N, O, X, C, L, B, R, and I, and then H. Remember that? Okay. All right, so I will put that back up here in a second. I just want to make sure you can find the practice problems. Those activity series practice problems, it's due tomorrow. Your quiz is, of course, on Thursday. Hopefully you saw that announcement at the beginning of the week. It's been up there. Download the problems. I want you to do them on a separate sheet, then you're going to upload your responses. Okay, just like we've done in the past. You're welcome to work with a partner. I have no problem with that. You're welcome to move to do so. Your goal is by the end of class. If you don't finish it by the end of class, it's homework. And I will put that activity series up here just in case you can't find it or whatnot. You're working on the activity series practice problems, and I hope you have a great day. If you have questions, please email.